would erode with it. It can't remain standing. It'd be a pile of blocks erode down with the plains. And so at the end, this is what you should see, just a pile of blocks. That's what Devil's Tower should be. But during the flood, Devil's Tower being a volcano, the flood current's going like this, would erode it. The volcano stops, you erode the top, and you're still eroding sediments, and then Devil's Tower being a little bit harder isn't eroded. And at the end of the flood, you erode these two sedimentary rocks further, and the tower hardly at all, leaving it an erosional remnant. That's how I think you can account for it in the flood. Anyway, there's erosional remnants, all over in the west. Shiprock in New Mexico is one. Monument Valley. We have a number of them in Montana. But anyway, they're either sedimentary or igneous, showing that the sediments were once much thicker. But to keep an erosional remnant vertical, especially a tall one like that, implies rapid deposition. Here is one feature that I've been checking out for 15 years. Quartzite is a metamorphic sandstone. It outcrops in the Rocky Mountains, your Rocky Mountains, and also up in Montana. But the grade of the quartzites I've been finding is high-grade quartzite. What happens is you heat up the sandstone, and it's sort of sandstone being mostly glass. It'll kind of melt and fill in the pores, and it'll be non-porous and dense and hard, very hard rocks, the hardest rock in the Rocky Mountains. So whatever eroded these rocks from the Rocky Mountains and spread them out into the plains, into the Pacific Ocean, whatever did that would keep the quartzite would become smaller with time, but the other rocks would be pulverized. So I've been checking where these are. Here's the big picture. When it's all generally flat in the area of the Northwest where I live, during the flood, the currents would generally go from west to east because of the spin of the earth. So if you're eroding the Rocky Mountains that are starting to rise up, and as they're starting to rise up, the current is just shearing off the rock and sending it eastward. And it rounds the rocks pretty fast, and as it gets further east, the rounding decreases. It gets smaller and smaller. The size of the rock, you might go from that down to that. And it'll end up way out in the plains. But then as the Rockies come up and break the current up, and you have currents going to the east and the west, it's going to start taking them towards the Pacific Ocean. Anyway, these quartzites I should have brought some. Oh, the plane wouldn't let me though, that's the trouble. But anyway, I'll show you pictures of them. This is they outcrop right in this area, right in here in general. Right along the Montana-Idaho border and in central Idaho, right in here, is where this grade of quartzites come. And it's part of this, what's called the belt supergroup rock right here. Anyway, west of the divide, we find them in these locations. I've been to many of these locations. These big green areas are large areas, and these triangles are small areas. Through Hell's Canyon around Lewiston, Idaho, there's a lot of it. Up on the top of the Wallowa Mountains, there's lots of it. In the top of the Blue Mountains, you find it. All through the Columbia Gorge, out to the Pacific Ocean, you find it. Up on the lava ridges around Yakima, you find it on the top of the ridges. You find the rounded quartzite, rounded by water. You even find it in Puget Sound area, mixed in with the glacial debris. About 1 out of 200 rocks in the glacial debris is a well-rounded quartzite. And I found in 6 locations, even on Camano Island, I found these quartzites. And the nearest outcrop, remember, is way over in here, and yet you find them across the Cascades in there. East of the divide, remember, they came from way over in here. Look at the scale. This is 100 kilometers. We find them on top of these plateaus. These are the top 2 plateaus or erosion surfaces or planation surfaces in the high plains of Montana and Canada. They're carpeted by quartzite rocks, 75 feet thick in the Cypress Hills by the billions. I even find them in this formation called the Empress Formation, which is underneath the glacial debris. Here's Saskatoon, Regina. It's northeast of Saskatoon in the subsurface. That's about almost 800 miles from the nearest source, because these quartzites don't outcrop on the plains. They outcrop near the Montana-Idaho border west of the Continental Divide, and yet we find them by the billions east of the divide, on top of plateaus, on tops of mountains, and even in the plains, even below the till. In Wyoming and Idaho, I find them in these huge areas right in here. Northeast of Jackson, Wyoming, they're up to 11,000 feet thick. Right here west of I-15, just south of Montana, they're up to 15,000 feet thick that filled up a huge crack. Remember, they came from out in here, and they're spread out on here. They're found on top of the Teton Mountains, on top of the Gravelly Mountains. Here is some found on top of the Wallowa Mountains in northeast Oregon, 8,200 feet. And that's the largest one we found up there, weighed about 400 pounds. Well rounded by water. In fact, it was so turbulent, this water, that there's gold in the finds. There was even an active gold mine in this area until they made it a wilderness area. The nearest source is 100 miles to the east across the current Hells Canyon, the deepest canyon in North America, even deeper than Grand Canyon. And here's the ones on top of the Teton Mountains. We did a 3-day hike, and we found them up to that big on top of the Teton Mountains. And here's what quartzite looks like. It used to be a sandstone, but it's been heated up and it's kind of glassy inside. They call it vitreous. That's one broken up. Here's one right here. Here's the largest one I found on top of the Teton Mountains. Here's one. Now they have these percussion marks. Remember, this is a very hard rock. One that size, I can hardly break it open with a rock hammer. It's so hard. But yet they're